Okay, class, welcome to Finite Mathematics. So today we're going to start this class and we're going to start the first video. And this is going to be over Chapter 1, Section 1, which is going to be on linear equations. And so we're going to start with this. So this will be a quick video. For Section 1, this is what we're going to be covering. Definitions, theorems, properties, examples, figures, and also tables. Okay, so section 1.1 is slopes and equations of lines. So this is an example of a coordinate system. So this is the Cartesian coordinate system named after a very famous mathematician philosopher, Rene Descartes. And so the way the Cartesian system works is that we have a rectangular coordinate system where we can describe the position of a point by given two coordinates in an x direction and y direction. And the legend has it that this came from Rene Descartes was laying in bed one day and noticed a fly on the ceiling, and he realized that, hey, I can determine the exact position of the fly if I know the distance the fly is from any two of the perpendicular walls. And so this gave rise to the idea of the coordinate system. So each one, now any coordinate system is, the Cartesian coordinate system is split up into four quadrants, and it goes counterclockwise. So it starts with this quadrant here, which is 1, and goes counterclockwise 2, 3, and 4. And over here is the positive in the x direction. So the two axes is the x and y axes. And the origin is always in the middle, which is where the two axes intersect. And that's what we call O, or 0, 0. So anything to the right and above, so anything to the right of the y-axis and above the x-axis is positive. Okay, so anything above the x-axis is positive. So everything up here would have a positive y value. Anything to the right of the y-axis is positive. So if you think about this as the number line, so everything on this side has negative x values. Everything on this side has positive x values. And then, of course, up here you have positive y values, and below the x-axis you have negative values. So then you know that anything that falls in this quadrant is going to be positive in both, right? So positive x and positive y. Anything that's in the second quadrant is going to be negative x and positive y. Anything in the third quadrant is both negative, so the x and the y are both negative. And then anything in the fourth quadrant is going to be positive x and negative y. And so you can get an idea of how this works when you look at points. Or now, once you understand how the system works, then if I give you a point, let's say 2, negative 2, then you'll know that, hey, that has to fall in the fourth quadrant because x is positive but y is negative. Okay, and by the way, there's the point right there. Okay, so that is our coordinate system that we use to determine where a point on a plane, the Cartesian plane, is going to be located. Now, intercepts. Now, the x and y intercepts are two special points depending on a line. So if you look at this line, the line here crosses the x-axis and the y-axis at 2 points. Okay, so it crosses the y-axis at point B, right here where B. So the y-intercept is B. A is the x-intercept. Now, typically, we can describe the x or y-intercept as a number, or some people prefer to write it as a point because the x-intercept is the point where the line crosses the x-axis. So that's going to have a x distance of a, and a y distance of 0. So the point here is going to be a comma 0. This point here is going to be 0 comma b. So now, what about the slope of a line? The slope of the line describes the rate of change when you compare how fast is x changing compared to how fast y is changing. So if I move a certain distance in the x direction, how far am I moving in the y direction? So it's a rate of change. And so for straight lines, that rate of change is always the same. It's constant, which means it doesn't matter what 2 points I use on the line, it will always give me the same rate of change. So if you take these 2 points here, you find that the change in the x distance to go from this point to this point, you have to go to a change of what? You have to go over how many units? Well, you have to count 1, 2, 3, 4, 5. So I have to go a distance of 5 units to the right. And then I have to go down how many units to go from this point all the way down to this point? I have to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have to go a distance of 9. Now, since I'm going down, I'm going in a negative 9. So I'm going down negative 9. So I'm going in the positive direction for x, which is positive 5, but I'm going down in the negative direction. So my change in y is negative 9. My change in x is 5. So delta x, that's the Greek letter of delta. So my delta x, which means change in x, is 5, and my change in y is negative 9. Okay, so how is the slope? So how is this slope changing? How is the slope of the line changing? Well, for every 5 units to the right, I'm going to go down 9 units to get to the next point on the line. And so that gives us our definition of the slope of a non-vertical line. So this is a straight line. So we're only dealing with straight lines here, not curved. The slope of a non-vertical line is defined as the vertical change, which often we call rise, divided by the horizontal change, which is run. So rise over run. So as one travels along the line, so in symbols, we take m as the slope, and we take the 2 points. We take point 1, which is going to be x1 comma y1. Those are the 2 coordinates that make up that point. And then we take another point that's on the line, and we call that point x2 comma y2. And so by definition of slope, we're going to take the change in the rise, right? Rise over run. The change in the y direction, which is going to be y2 minus y1. And then we're going to divide by the change in the x direction, which is run, which means x2 minus x1. And so we get change in y over change in x, which gives us this formula. So slope is y2 minus y1 divided by y2 let me say that again. y2 minus y1 divided by x2 minus x1. Okay, now another thing to realize is that I could switch these around. I could do y1 minus y2 as long as I switch the bottom as well. Okay, and I would have to do y1 minus y2, x1 minus x2, and I'll get the same answer. Okay, so just by construction that we use y2 minus y1 because we assume that this is the second point, this is the first point. Now, of course, we are assuming that x1 and x2 are not the same because we'll get 0, and we can't divide by 0. So let's find the slope of a line that goes through these 2 points. Okay, so now let's make this point 1 and this the second point. So now remember, we're going to do the change in y over the change in x. So let's make this y2 and this y1. So the first thing we're going to do is we're going to take 6 minus 5. And if we do 6 minus 5, then we're going to divide by the difference in the x's, which is run. So if this is y2, this is x2. So if we do 6 minus 5, then we also have to have 4 minus 1. Okay, now I could go 5 minus 6, but then I would also have to do 1 minus 4. Okay, so this is what they do. So again, we use our definition of slope, change in y over change in x. Make sure you have that memorized. Okay, rise over run. So 6 minus 5, right? 6 minus 5, and then 4 minus 1. And then, of course, you get 1/3. Now, if you switch these and do 5 minus 6 and 1 minus 4, you'll get the exact same answer. Okay? So now, what does the slope describe? The slope describes basically how steep the line is, right? So again, it's a change, it's a rate of change, right? How fast are we moving in the y direction compared to the x direction? And so we can look at the slope as the steepness of a line. So notice that if we have a completely horizontal line, the slope is 0. And then look what happens as the line gets steeper and steeper. The slope gets bigger and bigger. Okay? In fact, it gets bigger and bigger and bigger until we get to a vertical line. In fact, the vertical line is a slope that as this gets steeper and steeper, the slope is getting bigger and bigger, and it's heading off to infinity. Well, what happens when we have a vertical line? Well, what's the difference in the x's? Well, here, if I pick any 2 points on a vertical line, the x's are the same. And so if we subtract the same x value, we get 0 in the denominator. And so we define any vertical line, the slope is undefined. Okay, don't say that it doesn't have a slope. That would be incorrect. Avoid that language. We say that the slope is undefined. Okay, now, equations of line. So now we talked about slope and we talked about intercepts. Let's talk about the way we can represent lines. So one way we can represent a line is the slope-intercept form. And so the slope-intercept form, given its name, tells you exactly what you need. You need a slope, and you need the y-intercept. As long as you know, or excuse me, the y-intercept. As long as you know the slope of the line and the y-intercept, you can give the equation of a line, and you know what the line looks like. Okay, as you'll see. So if a line has a slope m and a y-intercept b, then the equation of the line in slope-intercept form is y equals mx plus b. So now, in this example here, it says find the equation of a line that has an x-intercept of -4 and a y-intercept of 6. Well, we have the x-intercept, but notice that they give us the y-intercept. So we know that b is equal to what? Right? Remember, the slope-intercept form, you have to have the slope, m, and you have to have the y-intercept. Well, we know what the y-intercept is. So guess what? Y equals mx plus b. 6 is our b. Now, what about the slope? How are we going to get the slope? Well, we could use the points that represent the x-intercept and the y-intercept. So what's the x-intercept? The x-intercept is the point, what? -4, 0. What's the point for the y-intercept? Well, that is what? 0, 6. So we can use those 2 points and calculate the slope. So I can do, so let's say in this case here, I can do 6 is my y, which means over here my y1 is going to be 0. So I'm going to get 6, and this is going to be my x-intercept. So what about x2? This is x2 is 0. I'm going to do minus, here is a -4. So I'm going to get a 4. So that means my slope is going to be positive. And sure enough, it is. So notice again, we get the y-intercept automatically. They gave it to us. And then to find slope, we use the definition. So again, we're using the x-intercept as a point and the y-intercept as a point. And so if we use the y-intercept, we get y2 minus y1 and x2 minus x1. Now notice they did it the other way. They did 0 minus 6, and then they did 4 minus 0, or negative 4 minus 0. And that's okay. You'll still get the same answer. And so now we've got the two pieces we need, and we're done. So we know that the equation of the line is y equals 3/2 x plus 6. And sure enough, if you check, if you put in 0, 6, you get 0, right? If you plug in 0 here, you get 0, and you get y equals 6, which is correct, okay? Now, finding the slope. Now, what if we give you an equation, some equation of a line, in this form? Okay, now this is not in slope-intercept form, but we want to know what the slope is. Well, guess what? We can put it in the slope-intercept form, and then once we put it in slope-intercept form, we know what the slope is automatically because we are familiar with the form, right? We know what the m and the b are. So all we're going to do is we're going to do this and solve for y and simplify in this case. Okay, so let's solve for y. So how we solve for y? You're going to take everything and move everything to the other side of the equal sign except for y. So the first thing we need to do is we deal with the plus, right? So here we're adding 8x. Well, we want to get the 8x over to the other side. So we're going to have to, since we're adding, we're going to subtract. So we're going to subtract the 8x from both sides because whatever you do to one side of the equation, you have to do to the other. So we're going to have this, we're going to subtract 8x from this side and 8x from this side. So that's going to give us a 3y equals 5 minus 8x. And then we've got this 3 times y, right? That 3y is multiplication. So in order to get rid of that 3, we want to divide by a number that's going to give us 1. Well, the only one that we're going to divide by is 3. So if we divide by 3, we get 1 here, which is great because that's just y. And if we divide by 3 on one side of the equal side, we have to divide by 3 on the other. So just solving for an equation. And so that's what we do here. So we subtract 8x from both sides. And then we divide by 3 all the way across, right? And so we get 3 divided by 3 is 1, so we get y. And then negative 8 divided by 3 is negative 8/3. And then 5 divided by 3 is 5/3. And this is our final result. So now we have it in the slope-intercept form. Y equals mx plus b. So the slope is what? It's the coefficient that's on the x when you simplify it. And so it's going to be negative 8/3. So negative 8/3 is the slope of the line. Now the other form that is very common is called point slope form. And again, the name kind of tells you exactly what you need in order to do it. You need a point and you need the slope. Okay, so this is also an equivalent expression of an equation of a line. Okay, you can take point slope form and transform it into y-intercept form easily. Okay, so again, point slope form is in this form. It's y minus y1 equals m times the difference between x minus x1. In fact, if you notice, this is directly derived from the formula for slope, because if you divide both sides by x minus x1, you get the formula for slope. But you only have one point, which is y1 and x1. Okay, and so this is where the point slope form comes in. Okay, so as long as we know one point, x1 and y1, and we know the slope, we could put it in this form. So let's look at these 2 points. Okay, so we have this point, right? So we got 2 points. We want to write the equation of a line that goes through those 2 points in point-slope form. Oh no, they want it in slope-intercept form. I'm sorry. Slope-intercept form. Okay. Well, in order to find the slope-intercept form, we need to find the slope and we need to find the intercept. Well, we don't have the intercept like we did before. So the first thing we're going to do is we need to calculate the slope. Okay, so the slope, again, we're going to use these 2 points, and so it's going to be rise over run. So y2 minus y1. So let's just do this one. Let's make this the second point. So we'll do 3 minus 9, which will give us negative 6, and then 5 minus 2, which will give us 3, and so that'll give us a negative 2, right, as a slope. So the first thing we're going to do is we're going to get a negative 2. Okay, so we found negative 2. Now that we got the slope, now all we need to do is use one of the 2 points. It doesn't matter which point we use because they're both on the line. They're both part of the line. So it doesn't matter which one you use. So what they did was they used 2, 2, 9. Okay, but you could have easily have used 5, 3. So now look what they did. They started with the point slope form. Okay, so look what happens here. You put it in point slope form and you just put in the 2 points for x and y. So you put in 2 and you put in 9. So now look at this. Now this is your equation of the line. Excuse me. Your equation of the line in point slope form. Now, to put it into slope intercept form, all you do is solve for y and simplify. So all you have to do is add 9 to both sides, right? So here they distribute the negative 2, and you add 9 to both sides. And so when you distribute the negative 2, you get negative 2x plus 4. And then when you add 9 to both sides, you get y equals negative 2 plus 13. And so now, look at that. You got your negative 2, which is the slope, and you've got a 13, which is your y-intercept. So 13 is your y-intercept. Okay. Now, this is not the only way you could have done it. You could have also just wrote y equals, let me see if I can do this. Here. You could have just wrote y equals, and then the slope is negative 2. Okay, and then all you had to do was just take one of these 2 points, plug in y, and plug in x, and then solve for b. So you could have done 2, 9, and just said, okay, well, this is going to be 9 equals, I'll do this real quick, I hope, and then this will be negative 2, and then this will be 2. Plus b. And so in this case, we're solving for the y-intercept. And so in this case here, what are you going to get? You're going to get 9 equals negative 4 plus b. Well, if you add 4 to both sides, what do you get? You get b equals 13, and you get the same answer. So you could use the point slope form and then solve and transform it into the y-intercept form, or use the y-intercept form and then plug in one of the 2 points. Either way gives you the same answer. Okay, vertical and horizontal lines. Okay, so we've kind of touched on this or hinted at this already. So now, this is a horizontal line. Notice that for a horizontal line, the points, regardless of whatever point you choose on the line, the y value is always the same. Horizontal lines always have the same y value, right? Because they're not going up and they're not going down. So they're staying the same across all values of x. And so the way we know that we have a horizontal line is two things. One, the slope is always 0, right? We talked about that before. Horizontal lines have a slope of 0, and their y-intercept is a constant, right? So y equals -4 is the y-intercept. In fact, this also represents the equation of the line. Because if you put in y equals mx plus b form in the slope-intercept form, well, since the slope is 0, well, 0 times x is 0, right? And so you get y equals b. And so the formula, or the equation of a horizontal line is always y equals b. Now, what about this one? Vertical lines. Well, no matter what point you choose on a vertical line, the x value always stays the same. So notice that this is 4 and this is 4. So no matter what value of y you choose, x is going to be 4. In fact, the x-intercept is 4. So in fact, the way you describe the equation of a vertical line is x equals a, where a is the x-intercept. So if it's a vertical line, it's x equals a. If it's a horizontal line, it's y equals b, and those are the equations of the line. So those are two special cases of where the general slope-intercept form reduces to a simple equation. Okay, slope of horizontal and vertical lines, as I said, the slope of a horizontal line is 0. The slope of a vertical line we call is undefined. And so here are the equations of the lines. So this is the summary of everything that we've talked about so far. So make sure you memorize these. Make sure you know these, okay, for quizzes, homework, exams. So now parallel lines. Parallel lines are any two lines that will never, ever intersect no matter how far out you take the lines. And the reason why they will never intersect is because they have the same slope. So the definition of two parallel lines are any two lines that have the same slope. Okay? Or if they're both vertical. Okay, which means both of them are undefined. But they are both either vertical or they have the same slope. So it's an if and only if, which means this is the definition. So parallel lines are two lines that have the same slope. So if you have two lines that have the same slope, they must be parallel. If you have two parallel lines, then the slopes must be the same, okay? Or they must be vertical. Perpendicular lines. Now, perpendicular lines are two lines that intersect at right angles. So when they intersect, they form right angles. Okay, so the definition of perpendicular line is any two lines where the product of their slopes is -1. Okay, or if one line is vertical and the other line is horizontal. Okay, that's the other special case. Okay, because you can't take a vertical line and slope of a vertical line and multiply it by the slope of a horizontal line, because the vertical line has an undefined slope. So that's why we add that. Okay, so now, so the other way of looking at the slope is if you multiply, so the one way is just basically saying if you multiply the two slopes and they give you a product of -1. If that's the case, the lines must be perpendicular. The other way of saying that is if one slope is what we call a negative reciprocal of the other. So if you take one slope and you look at the other slope of the other line, and one is a negative reciprocal of the other, then they must be must be perpendicular lines. Okay, now here's an example of where we're going to look at parallel lines. Okay, so it says find the equation of the line that passes through the point 5, 4. So we know that 5, 4 lies on the line and is also parallel to this given line, 3x minus 6y equals 7. So the first thing we're going to do is we need to put this in slope-intercept form. We need to find what the slope of this line is. Okay, because since we know that we want to find an equation of a line that is parallel to this line, we know that they have to have the same slope. So if we find the slope of this line, then we know that the slope of the other line has to be the same. So we're going to solve for y. So if we solve for y, well, we subtract 3x from both sides. We get 7 minus 3x. And then we divide by negative 6. Okay, so we're going to get 1/2 x, 1/2 x minus 7/3, I believe. Oh, 7/6 rather. I'm sorry, I forgot. Divide by 7/6. Okay, and so that's what we did. So here we look at that. So we subtracted 3x from both sides. So we get a negative 3x plus 7. And then we divide by negative 6 on both sides. And so this reduces to positive 1/2. So we know the slope has to be 1/2. Okay, we don't care about the y-intercept in this case because that's not going to help us with this problem. We want a parallel line. So the first thing we do is we know the slope of the line has to be 1/2. Okay, so now that we know the slope of the line that we're looking for 1/2, but we also now we got this point, and since we have this point, we can go ahead and solve for the intercept, the y-intercept. Okay, because now we can just plug in 4 and 5 into our general equation with the slope of 1/2 and solve for the y-intercept, and we've got the equation. We're done. So we know that the slope of the line passes through 4, 5. And so what we're going to do is we're going to substitute 1/2. Now, again, they use the point slope form, and that's fine. But you can use the y-intercept form to solve for this too. And so they plug in 1/2, and they take the point 4, 5, and they plug in 5 for y, and 4 for x. Okay, and so now what you do is you simplify it. Right, so you get 1/2 x minus 2 here, and you get y minus 5. So if you add 5 to both sides, you get 3. And so what happens is now this is the equation of the line, and you're done. Now what about perpendicular lines? Well, let's say we've got this case. We've got the point here. Let's say we want to find an equation of a line that passes through this point, but is perpendicular to this line. Well, again, we need to find the slope of this line first because that's going to help us find the slope of the line we're looking for. Okay, so again, we're going to solve for this. So we're going to subtract 2x from both sides, and then we're going to divide by 3 on both sides. And so this is what we get. So when you solve here, you get y equals negative 2/3 x, right? Plus 4/3. Again, we don't care about this. We just care about the slope. Now, how do we get negative 1? So we know that they're perpendicular. We're looking for a perpendicular line. That means that we know that the two slopes, the slope of both lines, must have a product of negative 1. Or in other words, a negative reciprocal. Well, what is the negative reciprocal of negative 2/3? Well, the reciprocal of 2/3 is you flip it. So the reciprocal of negative 2/3 is negative 3/2. You just flip it upside down. Okay, and then the negative reciprocal is you just change the sign. So we know that the slope of the line that we're looking for has to be 3/2. Okay, so now that we know that the slope of the line is 3/2 and the slope and the line that we're looking for goes through the point 3, 2, so now we can do the exact same thing that we did before with the last problem, which is use either the point slope form or we can use the y-intercept form to find the y-intercept, and then we're done. And so again, they decide to use the point slope form. And so they plug in the 2 points, x equals 3 and y equals 2, so the point 3, 2. And so then once you plug in your point and the slope, you just solve for y and simplify. So you distribute the 3 halves, so you get 3 halves x minus 9 halves, and then you add 2 to both sides, and you simplify this here by just changing this into 4 halves, and you get minus 5 halves. And so you get y equals 3 halves x minus 5 halves as the equation of the line that is both perpendicular to the given line that we were started with, and it also goes through the point 3, 2, because if you put in 3 here, you get 9 halves, and 9 halves minus 5 halves is 4 halves, which gives you 2, and that's the other point too, so it works out. Okay, so now let's talk about this. We have two graphs here, and so in this here we have 3 points, right? So let's say we have a line and we're trying to graph the line, and we know that these 3 points are on the line. Well, we can form the graph of the line by connecting all the dots. Okay. Now, the thing is that we can use any two of these points. We could use these 2 points to find the equation of the line. We could use these 2 points, or we could use the outside points. And the thing is we only need 2 points to get the equation of a line if it's a straight line. And so in any case, we can find the line, which is negative 3 halves x plus 6. Now in this case here, we notice that they've got the y-intercept 0, 6, so we know b is equal to 6. And then we can use any two of these points to find the slope. And so once we have the slope, then we can write the equation of the line, and we know the line goes through this point here, and this point here, and this point here. So we only need 2 points. So one method of finding the slope, or excuse me, not the slope, but the equation of a line is called the intercept method. And the intercept method is you just find the y-intercept and the x-intercept, and then once you have those 2 points, then you can get the equation of the line. So graph of a horizontal line, as we said, goes horizontal, right? So again, it's always going to be y equals b, where b is the y-intercept. Okay, so it's always y equals negative 3 in this case, and it's a horizontal line. So the equation of a horizontal line is always going to be of that form. Okay, so let's look at an application type problem. So let's look at tuition and fees. So the table on the right lists the average annual cost of tuition and fees at public four-year colleges according to the College Board. So given this table of data, we want to plot the cost of public colleges, and we're going to let year 2000, so we're going to assume that the first year is t equals 0. Okay, so that's what we're going to assume. So this would be t equals 0, this would be 2, 4, 6, 8, 10, 12, and then 13. And so we're going to plot this data and see if it gives us a straight line. Is it going to be perfectly straight, or is it going to be approximately straight? Could we use it? Could we model it using a straight line? Well, let's look at it. Well, yep, if we plot it, notice that 0, so here's the first point, so here's all the points. Notice that it is not a perfectly straight line, but it's fairly close. And so, yes, I would definitely say that this could be modeled using a straight line. Well, how do we figure out what line to use? Well, we could use any two of these points to calculate or estimate, rather, the equation of a line. Okay, so definitely we could model this with a linear, with a straight line. And so now, what line are we going to use? Well, part B says, well, we're going to use specifically 2 points. Okay, and the 2 points we're going to use is going to be Oh, did I miss that one? I think, if I remember right, they're going to use this one and the last one, I think is what they used. Okay. But the first thing we need to do, oh yes, there are the 2 points. Yep. So it says part B, it says use these 2 points. So the first one and the last one is the 2 points that they used. Now, could they have used 2 other points? Yes. Okay. Would they have gotten the same equation? Probably not. They'll probably get something slightly different. Okay. If you choose 2 different points, because this is real data, it's not perfect. So if you choose 2 different points, it's going to give you a slightly different equation of a line, right? All the other examples we've done so far have been like we're assuming they're straight lines. In this case, we're using real data and we're saying, hey, is the data straight enough to approximate it with a straight line? And so we just use these 2 lines. And so, of course, we have to get the slope. So we use our slope formula. And we find that the slope is 414.2. Now notice that we go out to four digits here. And that's because the data that we have is 4 significant digits. So we want to make sure we have 4 significant digits in our approximations. Okay, and so this is what we approximate out to 1 decimal place in this case. Another one to use is we always go out 1 more decimal place for accuracy is another way to look at it too. So now what does this mean? Well, this 414.2 means what? Well, what's the units of y? The units of y is tuition, average tuition, okay, annual tuition. And this is the year or number of years, right? So what does this mean? This is tuition dollars over year. So that means that for every year that goes by, the amount of the average amount of tuition and fees goes up approximately $414.20 on average. Okay, so that's the interpretation of the slope. Okay, that's going to be critical. You have to be able to interpret the slope in the context of the problem. So that means that the tuition is going up on average about $414.2 per year annually for tuition and fees. Okay, so now using the slope-intercept form, we have y equals m times t, which is time, so that's our variable, plus b. We know the slope already. Well, the y-intercept, that's where t equals 0. Well, we got that one too. Okay, that's one of our points. And so now we just plug it into our formula, and we know that the equation of the line that represents the relationship between time and tuition and fees is this equation right here. Okay, and so the slope we've already interpreted. Well, what does this mean? That means that in year 0, the average tuition was about annual tuition was about $3,500. Okay, $3,508. Okay, and that ends this video. So next time we're going to talk about linear functions and applications in section 1.2. You have a great day, and I'll see you later.